So today our topics are going to be, how and when to use certain toolpaths. Obviously there's going to be different scenarios where you have to use certain ones, and sometimes it comes down to a preference based on how you're machining it, what the material is, what your tooling is, all that stuff's a factor. So today we're just going to kind of cover, in a way, just some of what the toolpaths do and how you can use them and stuff like that. So if you guys have any questions while we are going through it on the particular subject we are covering, go ahead and shoot. You guys can start typing away those in the questions tab. I'll be able to answer them as we go along. We're also going to be bouncing back and forth between the PowerPoint and the actual webinar software as well. Okay? So to start it off with, let's go ahead and start with changing. Okay? So basically we're going to be covering a lot of the 3-axis Pro toolpaths for this particular exercise today. We're going to be going over some of the roughing, flat surfaces, surface edges, fillets, just when to use them, how certain toolpaths can be utilized, and stuff like that. Like I said, if you have any questions on it, please let me know as we're going through it, and that way we can answer them as we go along. So the first thing we're going to do is we're going to cover some of the roughing, okay? You have your standard roughing, and then you have options like advanced roughing, okay? If you guys look at the image here, I actually have this particular part. With your traditional roughing path and just using just a regular Z-level rough, your tool will go right to the edge, but it doesn't go past it. So with the advanced options, you're actually able to go past the option of that wall. So it'll actually cut past it based on the stock info and the model, okay? And I'm going to show you guys how that works. All right, so first things first, we have our part, okay? And I'm going to flip you guys over to that screen now. All right, you guys should be able to see that screen now. It's loading. Okay, so the first thing we're going to cover is we're going to go ahead and start off with the setup. So we need to go in. We have our machine picked. We're going to do a mill 3-axis. We're going to hit our stock wizard, and we're just going to set up the stock, okay? Now, one of the interesting parts, if you guys do notice, just as a side note, this part is flipped on its side. What we're going to do is we're going to go ahead and adjust the actual 0 on it. So we're going to put origin in this corner here, and then we're going to adjust the Y direction, click this line, and then we have our X direction this way. So what we're going to do now is that we have that defined. We're going to go ahead and hit OK, and it loads in our settings. So the first thing we're going to do is we're going to right-click on the stock. I always blank mine out, and I'm going to right-click on Machine Setup. Down in here, we're going to find the 3-axis tab. We're going to click on that. And that's going to allow us to open up the wizard. Once that wizard launches, we're going to pick our geometry. Again, we're going to select it, right-click OK, and then we can go ahead and hit Next. Okay? So through here, you're going to find your options to program for your machining part. You're going to find, rapid plane, your feed plane, top of feature. If you want to change the top of the start of the feature, you're going to hit Next, and you're going to choose your strategy type. So what's really nice is in here you're actually able to go in and actually do your different strategies. Obviously you'll have different strategies based on what you're trying to do. So in this case we're going to choose Advanced Rough. Now what we're going to do is once we choose Advanced Rough, we're going to hit Next. And once we hit Advanced Rough, we're going to go down and define the tooling. Okay? So what we're going to do is we're actually going to use a 1/2-inch tool to start off with no corner radius. You guys can adjust your feed rates and everything. But what's going to happen with this particular toolpath is it has offset, which is just going to follow the shape around. You have parallel, and these are all different options. And picking the one that suits you best depending on the part. We wouldn't use a parallel on this. We have adaptive, which is the high-speed style of machining. In this case, we're actually just going to use the offset. We're going to choose a zigzag option. And then when we hit Next, you have your parameters tab, okay? So we're going to say let's take 2 depths of cut, or 1/4-inch depths of cut. And we're going to step over 1/4 of an inch just for the example. And then we're going to leave a little bit of material if we were to do a finish pass in the XYZ allowance. Once we've done that, we have our lead-in options, okay? And then if we go ahead and we hit compute, we're going to calculate and see what it's machining. And this is where it comes down to that aspect. We actually have a question on rest roughing. We're going to use it on this particular feature, okay? So if you guys look from this view, okay? We can see that we're machining everything pretty nicely. It's cutting past those walls, which is really nice. That way you guys can get right past that wall. But if you look in the center, and if we were to launch the simulation, let's go ahead and launch it for you guys so you guys can see, we're not getting all of that center cutout. And the reason for that is the tool is just too big to get in there. So if we go ahead and we hit run, we can actually watch it start machining. We'll speed it up a little bit. Okay. So if you guys look, it didn't cut all that cutout out. So what we have to do is we need to add a rest roughing because we still want to use the same tool. We don't want to have to shrink and use a smaller tool to cut the whole part. We want to actually go in and use a smaller tool to clean up those areas. So what we're going to do is we're going to exit out of there. Now, in version 29, 28, and all those ones, you can right-click here and edit the feature you already created. You can go to your strategy, and you can actually go down to the advanced rough, and you add a second one. The reason why you add a second one is now, if I go in here, I have my setup for my first one, right, with all my parameters defined. But I go down here to this one, and I'll shrink the size of the tool to 1/4 of an inch. Then I will go down and set up my depths of cut and my step over. You can set it to what you need. You want to leave the XYZ allowance the same. And then if you go down to the options tab in the actual 3-axis roughing, you're going to find a rest roughing option. What you're going to do is you're going to turn that option on. And if you look here, you have an option for a checkbox that's called Use Previous Operation, which takes the operation info from the previous one. It brings it in so you guys don't have to fill it. If you look, it's all filled out for us. And we just hit compute. Let's see what we get. All right, and we're going to change the color of the actual rest roughing to a different color just to make it easier on us to actually be able to see it. So I'm going to go ahead and change that toolpath color for us. Go down to the color, and we'll just change it to orange. So if you guys look at it right now, you'll see that it's getting in the corners over here. It's also handling, if we look from that view again, it's actually handling the area that the first tool couldn't go. Hold on one sec, guys. All right. All right. So once we go ahead and we have that, if we go into the simulation now, let's go ahead and launch that back up so we can actually see that it handles that part. All right, let's go ahead and hit run and let it rip through, and you guys will actually see. The nice part too, if you guys don't know this in the simulation, you guys can actually go in, and if you hit pause, you guys can say next op, which will just jump to the next operation. So instead of you guys having to watch the whole operation of the first one go through again, you guys can just skip to the next one, and that way you can just focus on that. So let's go ahead and slow down the speed just a little bit. We're going to hit play on that, and we're going to watch it. So if you look in here, it's actually going in to handle those corners that it calculated that are still have leftover stock, and then it'll go into the centerpiece as well, and it handles all of the centerpiece for us. All right. Now, those little red dots right there normally indicate a collision, okay? It's actually not a collision in this case. It's because the tool is just plunging down in there and there is material left over. It is something that we are working on handling, but guess what? The best part is that actually isn't a collision. Because if we go ahead and we turn on the workpiece, just so you guys can see, this might come up where you guys have noticed it. If you look, we still have material in that area. We're not actually colliding or cutting through. We still have material to remove with maybe a Flatlands or something like that, which we're going to cover as well. Now, as you guys can see, we handled the rest roughing. So that's how you guys decide if you're going to use a rest roughing. That's how you decide the style of roughing based on the part itself, okay? Now, let's go ahead and move on to another subject of it, okay? If you guys have any questions about roughing and using advanced rough, go ahead and type those away. I'll jump onto the next subject and then go back to it if I need to, okay? All right. Now, what we're going to do is we're going to go ahead after we have that, and we're going to move on to the next subject, and we're going to use this part. So we're going to pop over to the PowerPoint to kind of cover what we're going to go over. All right. So you guys have the scenarios where you guys have nice steep walls or tapered walls, and you want to finish them, okay? So what we're going to do is we're going to go ahead and cover that, okay? So in this particular scenario, I have areas where I need to cut up here, and I need to cut down the steep wall. So what I'm going to do is I'm going to go into and set up the job. Okay? And what we're going to do is we're going to use a couple different toolpaths, and I'm going to kind of show you guys what the options are. So if we go down here to Mill 3-axis, we select our geometry. We're going to select the part itself, and then we'll right-click OK to confirm it. Then what we're going to do is we're going to turn on a Z-level. Okay? We're going to turn on Equidistant, and we're going to turn on Advanced Z-level finish. Okay? So if we go ahead and we hit Next, we're going to go in and we're going to use, let's just say we're going to use a 1/4 ball end mill. Okay? If you look here on the Patterns page, you're going to have Climb and Conventional. And then on the Parameters page, you just have your depth of cut. Okay? Now, if we go after that, we go down here to the leads. You have your lead-in options. And then you guys are going to have extra options in the tab for inner, outer, okay? These have option. This particular toolpath has the option for you guys to just say, hey, cut innermost only if you select the whole solid, or outermost only, or all of the part, okay? Now, if we go down to Advanced Z-level finish, we're going to set this up as well with the same tool. When you go to the Patterns page, you're going to have a little bit more options. You can say start from top, bottom. You can zigzag, or spiral. All right, and then you have Climb or Conventional. Then you're going to hit Next, and you have your depth of cut. This one also has options like Machine Flatlands, which actually will take one final pass at the bottom just to make sure it gets it. And then you also have Machine Vertical Walls Only, where it doesn't cut any tapered walls. It will just cut vertical walls, okay? And then you have Adaptive Depth Cuts, which helps compensate on those tapers. But what we're going to do in this case is we're just going to leave that stock as well. The other option is in the Options tab, you're going to have Rest Finishing. So we just covered Rest Roughing. Rest Finishing does the same type of thing that the Rest Roughing does, except it goes in and finishes the area with a ball mill. Then you guys also have Angle Range, which is another option, which is really nice. If you're doing anything that has any angles, you can just type in that range of angles so it only calculates on there. And then what we're going to do is we're going to go ahead down to Equidistant now, and we're going to set this up. Now, Equidistant is designed to cut all over the model. And the reason why we're using this one for this particular setup right now is we're trying to compare 3 toolpaths to figure out what is the best and how to pick the best one for exactly what we're trying to do. So if we go ahead and we just leave it at the default and we set everything, we hit compute, we're going to calculate all 3, and then we're going to dissect it. Now, while we're waiting for that to cover, what we'll do is we'll go over what we're going to cover next as well, and that way we're just kind of keeping the process going. Okay, so next we're also going to cover flatlands, okay? There is a particular toolpath we have for just cutting the flat areas. Now, flatlands is a good choice when you have any type of flat area you're trying to machine. It's nice for inside pockets, open shapes, different options for it. So keep that in mind that you can use flatlands for that aspect. We're also going to cover some of the surface edges, picking different edges. Some of these actually have drive curves like Equidistant, so you can pick a drive curve to follow. And filleting. I mean, you have two different options for filleting, okay? Normally you have, if you have a corner round tool that's big enough to create your fillet, great. You can use the corner round tool and use that in the 2-axis. Now, if you don't, you need to use a ball mill and step down. There's a couple ways you can do it. So we'll go over, kind of using, a couple different tool paths to kind of cover getting those fillets. And then that'll pretty much cover everything that we're going to cover today. We're trying to keep this one pretty simple and pretty basic, just kind of covering some of what the toolpaths do. Obviously with you guys working every single day and programming your parts, there might be some things that you're not using that you guys should be using, and hopefully this helps you guys with figuring out, am I using everything? Am I getting the best out of it? Can I cut down on some machine time? Those type of options. And then we're obviously preparing, just so you guys know, we're preparing the rest of the webinars for the future and getting everything sorted out with that. Also, as a side note, we are going to SolidWorks World in Los Angeles in 2 weeks. We will be at SolidWorks World. I don't know if any of you guys are going, but we will have a booth there at SolidWorks World, so if you do want to swing by, go ahead and do that. All right. Also, just keep in mind that the video will be recorded, so you guys can go in. We will eliminate some of those areas where we were having the calculations, so don't worry about that. So if you look here, what I ended up doing was I ended up getting rid of this one. We're going to go here and blank out the Equidistant, okay? So right here, if you look, this is just the regular Z level, okay? If you guys notice, it's not touching the top. It's not touching the flats. It's just handling tapers. Even right here, see how this is spread out? That's going to leave a bigger scallop. It's not designed to cut all the way across it. It's more designed for getting the walls, okay? Now, you could go to Equidistant and cut the whole entire model, right? But maybe you don't want to do that. Maybe you want to do a different toolpath. Maybe you want to use the Flatlands and then maybe just handle the radiuses. You can do that type of stuff, okay? Now, what's going to happen is you can actually go in here, and what you're able to do is you're able to actually go ahead, okay? So let's just kind of look at that, and then let's get rid of this one as well. Okay, and then there's the advanced, okay? Now the advanced Z-level finish versus the regular finish has an extra couple options, okay? And what I mean by an extra couple options, so we can't do anything to the Z-level finish. It's calculated, those are the settings it has. So when looking at the toolpath and what you should use, sometimes it's better to go in because maybe I can get it to do this, okay? So what I could do is I could go in and you can mess with certain options in here, like adaptive depth of cut, to help compensate when that scallop gets a little bit bigger as it goes down the surface. You have those options that necessarily aren't available in another toolpath. So you guys can turn that option on, set a maximum step over distance, and then let it calculate and it'll help, okay? Now, the other nice side with it is Equidistant is a great toolpath, especially if you're cutting just across a 3D surface. In this particular scenario, it might not be the best choice for us because it's going to cut everything, okay? So we might want to use this and combine. You could go in, and like I was talking about with the Equidistant in particular, is you guys can actually go in to the parameters and just pick a drive curve, okay? And what it does is when you guys run into that scenario where you have pockets and stuff and you're using a 3D toolpath to surface the whole model and it starts to drop down in those pockets, if you look at this image here, this is a great example. It's dropping down in there and then coming back out. If you pick drive curves, you can actually pick the curves, and what it does, it'll actually cut around, cut around, cut around, and then go down and handle them, as opposed to you having a tool, going, ramping down in there and coming back up the other side of the wall. It actually makes it more uniform, okay? So there are options like that that help with picking it. Now, another option, too, if you want to, you can go in. So we were talking about angle ranges, okay, and handling fillets. So in filleting, right, if we dive on into the fillet section in here, if we go ahead, we go in here, and we go down to mill 2-axis, we do have the option for you guys to properly output a corner rounding tool with the settings, and it properly offsets and does the calculation properly. But necessarily, we might need to go in and use a ball mill or something like that. So what we're going to do in this case is we're going to go down here, and if we want to use Equidistant to get it, we could actually just define an angle range, right? And what we could do is define an angle range to get it to only cut on certain portions of the angle. And I'm going to show you how that works as well. If we go in here to the options and we turn on the angle range, okay, you can set that range of an angle. So what I could say is, you know what, let's do 0 to 30 just so you guys can see. Watch what happens when we do that. So we're going to go ahead and hit finish, and we're just going to recalculate only the equidistant with the angle range option turned on, okay? So what it's going to do is anywhere from 0 degrees to 30, it's going to calculate Toolpath. Anything greater than 30, it's not going to touch. Good. So if you look there, see how that toolpath is only cutting in that angle range? So what's nice about it is you can turn on those options. So yeah, it's handling kind of the flat areas, it's handling the radiuses. Okay, we can make it, we could go to 40 degrees, go a little bit further down if we want to. It does the same here. So what it does is it analyzes the model and finds those angles. So you guys can turn on that option and use it when there's that scenario. Now, there might not always be that scenario where you want to use it that way, but you can start playing with it to actually go in and start using it on different models, and you can go outside that or inside that range. So you could say, okay, well, I don't want to cut anything between 0 and 25 degrees. So you just set it, and then you say, in that option, I'll show you guys, there's an option when you define an actual range of an angle to go in and just say machine outside slope angles or machine inside the slope angles. So you don't necessarily have to try to figure everything out. If you just go, okay, well, I know that's 0 to at least 25. I'll just machine outside of that. You type that in, you hit that, and it calculates that particular way. Now, we've covered that. We've covered a couple of the surfacing options and how certain ones with better options can help you guys produce faster machining or better quality machining. So let's go ahead and use a couple other ones. So what we're going to do is on this particular part, we have quite a few flats. So let's go to Mill 3-axis, hit Select Geometry. Again, let's process that model, and let's turn on the actual Flatlands. Okay. What's nice about it is you can actually go into Flatlands, and you just define the flat end mill you're going to use, however far you're going to step over. And then what you're going to do is you're going to go in here, and we're just going to hit compute and let it process. Now, it's only going to cut on those flat areas, so it's going to hit this here, this here, this here, this here. So wherever there's a flat. So, and the nice part about it is, if you use Flatlands for that particular type of scenario where you're just having to go in and clean up the flats, you guys can also turn it on in Advanced Rough. On the rest machining page right under it, it'll actually say Flatlands. You guys can turn it on and use that same tool to just cut the flat areas now, as opposed to having to do a separate tool path just to get it. If you don't mind using that same tool to cut the flats as you did with the roughing, it'll handle it that way. So if you look there, now we have this set to zig, so there are rapids. That's what you guys are seeing obviously there. It's rapiding up and moving over. But as you can see, it's only cutting the flat areas, and it's not cutting all the way up against onto this because it knows it needs to leave the material there for finishing because it's not a flat option. So you guys can use Flatlands to help you guys with cleaning up that area, and then you guys could use the advanced Z-level finish to cut all the walls only. If we just go here for that example, see, those toolpaths combined have just finished that model for us, and we didn't have to do anything extra. So instead of you guys having to cut around and trying to do boundaries, I used one toolpath to cut the radius areas and the walls, and I used one toolpath just to cut the flats. All right. Okay. Now another option, we had this question. I want to answer it. there's sometimes where you have a casting, okay? And you have the model itself and the casting, okay? And you just want to machine the material that needs to be removed for the casting, not the whole model. Because you're not using a whole block, you're throwing a casting in the machine. And you're just machining, whether it's cutting a couple walls, some pockets, or some slots. You guys actually have the ability to go ahead yourself, okay? And in here, in the actual advanced 3-axis surfacing options, under the actual parameters tab, there's a trim to stock option, okay? When that option is turned on, that allows you guys to load that other model that is the casted model without it being machined, because you'll have the model that needs to be machined, that is the final shape, and then you have the model that you can lay on top of it. When you turn on this option, you have to go over here and you have to assign operational stock. When you right-click on it, it's going to ask you guys, just so you guys can actually see, solid and STL. So if it is a solid model, you can select it, and if it's an STL, you can select that. That way, that toolpath now will be confined to only calculating, and it runs the model versus the actual stock model, STL or solid model together, and only cuts in the areas that need to be cut based on that parameter. So you guys can use those toolpaths for that particular option and picking that properly, so that way you're not sitting there wasting time with trying to calculate toolpaths, you know, and trying to boundary them off or try to keep them from going past certain things. If you turn that option on, it does help with that particular scenario. All right. So now let's go ahead and cover a couple more items, and then what we'll do is we'll wrap it all up and everything like that, let you guys get back to work and everything. So what we're going to do is we're going to go ahead and we're going to cover one other toolpath. Now this is a little bit further into the advanced options, okay? So you have an option for toolpathing, okay, that is in our advanced multi-axis, okay? Now when I say multi-axis, that doesn't necessarily mean, it is called multi-axis, but it doesn't mean that they're only going to be, okay, for, 4 or 5 axis. These toolpaths are used for 3, and they are our advanced surfacing options is what we call them. What you're able to do with the advanced surfacing options is do stuff you normally couldn't do. You can do true undercutting, okay? You can actually go in and pick, parallel to multiple curves, and we're going to use this toolpath for an example. So let's just say I go in, parallel to multiple curves, I select, I'm going to use a ball mill for this example, and I go into the parameter side of it, and what I'm going to do is I'm going to select an edge curve. And what we're going to do is, if you just go ahead, for example, and I right-click here, and I just say constant Z, and I select that as my curve, okay? I hit OK. That is the curve, and that is the shape the toolpath will start to follow. These toolpaths then allow you just to pick the drive surfaces that you want to machine, okay? All right. So when you pick drive surfaces, you can pick whatever surfaces you want. When you right-click OK, that confirms your selection. And these toolpaths in particular will have more options for you guys to get a different toolpath output. So in here, the tool axis control, yes, you have to change it from the 4-axis and the 5-axis to a 3-axis output. That tells the software, hey, it's only for 3-axis. But you guys can go ahead, and there's options like, okay, well, let's round the corners. Let's extend and trim the toolpath. As opposed to you guys having to draw an extended surface, you can say, hey, you know what, just extend the toolpath 1/4 of an inch, and it's going to take and extend that toolpath 1/4 of an inch. It also has the ability for you guys to control the step over by the cusp pipe. Some people ask for that option. It's not in our 3-axis Pro currently, but it is available in our option for you guys to actually go ahead and use these options. If you purchase them with the 4-axis Pro, you guys can get the advanced option. You can also handle, surface options, and you guys can also handle how many engagement points, which can help lengthen or shorten the code. If I go ahead and I hit compute based on that setting, let's see what we get. So let's go ahead and blink this out. and let's just take a look at it. So, all right, if you guys look, see how it cut this, which is what we selected as a drive surface. But then see how I left those gaps in there? And you see how the toolpath only cut the surface portion that I selected? That's how in-depth those toolpaths can go in that advanced option. You can have it follow it. Now, maybe I don't want necessarily all these rapids. Well, how can you control that? People ask that question. What happens if I have a gap? What happens if I have, you know, a pocket area and I just want to cut across it? I don't want to go down. I don't want to have it wrap it up and move over. These toolpaths have that option. So you guys are able to go into this particular toolpath, okay? And you guys can say, okay, let's go to the parameters, and then we're going to click on the actual linkage, okay? In here, you're going to have entry, lead in, lead out. You're going to have gaps, and you can define a small gap either by a percentage or a value, and then you have large gaps. Well, small gaps are direct, and you guys can set it to direct. Follow the surface. You guys can have it retract, okay? And then the large gaps, you can do the same thing. You can say, you know what, just go direct. I just want you to cut. So what it does is instead of it dropping down in there, wrapping it up and moving over, it just keeps moving on the machine, and it just follows it up to the next surface and then continues cutting. Those are those type of options. Now, link between slices. So you have small moves, where you can just do direct or blend a spline or follow the surface. And then you also have retract options on bigger moves. Well, you guys can set those to be direct. What you're doing by setting everything to direct is you're actually eliminating rapid moves. You're eliminating unnecessary moves that necessarily don't need to be there. So when going in here and using Toolpaths, if you're asking questions like, well, how can I control the rapids? Well, how can I control this? These Toolpaths have that option. So you guys can go in and actually define specifically how you want it to control, because a lot of the rapids are because it has to move from one location because the link between a slice or something like that is different. In here, you have those options, and you guys can set those. Also, the nice part too is the 3-Axis Pro. Also, we took the gouge checking ability and added that into the 3-Axis Pro, but this one was the originator of being able to use gouge check. So keep that in mind, guys, as you're going through it, that not necessarily is the toolpath you're using wrong, but there might be another option or another option in that toolpath that can set it up. And if you actually want to get trained on, you know, certain parts of yours that you might want to try to cut down some time, yeah, it takes a little bit of time to sit there and mess with them and get them just right, okay? But you guys can actually go in and set different things and change different things, and you can get a completely different output. Obviously, you're trying to get the part on the machine and get it going, and I completely understand that, but there's some times where you need to step back for a second at it, and you could save yourself, you know, 20, 30 minutes on each part. And if you're running large production runs, that's a huge savings, okay? So I appreciate you guys coming. Sorry about the delay on the laptop. I'm trying to calculate everything. It is a new laptop that we're trying to hammer out all the kinks. I got to, you know, delete some programs and get more power to it. I do appreciate you guys taking the time to come into the webinar. We will be setting up the next set. If you do have any recommendations, I have been trying to answer all the emails that are coming in. I'm also now handling educational and everything as well for our company, so I'm always across the board. Please let us know if there's anything we can do to help you guys or anything that we can do to improve what we're doing. If you have any suggestions, we take those and I try to adjust based on your guys' suggestions, because I appreciate you guys coming in each week. We will take the recording, obviously chop out a few things, get it ready, put it on the web for you guys if you want to rewatch it just to kind of see some of the settings and how we went. And again, I do appreciate you guys coming each week. Until next time, I'll talk to you guys then.